How's it guys? So today we're going to be doing multiplication and simplification of brackets, where we'll also be touching on trinomials and some difference in two squares. So coming into grade 10, we're sort of going a little bit back to grade 9, where we're learning how to multiply out of brackets. So let's start with a simple example. We've got 3x cubed minus 2xy plus 5. Right. How do we multiply this out? So inside my bracket is what I need to deal with first. So we've got an x cubed minus 2xy plus 5. We've got three terms inside our bracket, which we would obviously call a trinomial. So because we cannot add any of these together, I'm going to simply be multiplying this 3 by the x cubed, the negative 2xy, and the positive 5. So 3 times x cubed is going to be 3x cubed. 3 times a negative 2 gives me a negative 6xy plus 15. Nice and straightforward. Alright, so let's take a look at our first example we've got here on the board. We notice that we have two brackets with two terms in front of each bracket. So in regards to us trying to work this out, first we need to do is multiply out our brackets. So the first trick is to look at our two brackets. Do we have any like terms inside these two brackets? What I'm trying to say is, can we actually simplify what is inside our brackets? Well, in the first bracket we got x squared and we got an xy over here, so those are not going to be like terms. And in the second bracket we got an x and a y, which again are not going to be like terms. So what we're going to aim to do here is simply multiply these brackets out with 3 times an x squared and then 3 times the negative 2xy. For those of you who don't really understand that, if we had to simply use straight up constants, if I had 3 bracket 2 plus 3, there's two ways I could do this. I could say, well, I can do 2 plus 3, so I can simplify that to 3 bracket 5, which means 3 times 5, which gives me 15. Now, if I had to do it by multiplying the 3 by my first term and the 3 by my second term, what did we get? 3 times 2 is 6. 3 times 2 is 6, plus 3 times 3, which is 9. And what is 6 plus 9? 15. I know this sounds very easy, but what it's trying to teach you is that if I had to multiply what's outside my bracket by each individual term, I'm going to get the same answer, because 3 times 5 gives me 15, but then also 3 times 2 is 6, plus 3 times 9 gives me the 15. So don't stress about that. So 3 times x squared gives me 3x squared. 3 times a negative 2xy. Let's first deal with the coefficients. I got a positive 3 multiplied by a negative 2. That gives me the negative answer, 6, and then xy. And we now move across the next section. I've got a negative x multiplied by x, which will give me a negative, because a negative times a positive is negative, x squared. Now I've got a negative times a negative, which gives me the positive 7. There's always an imaginary 1 in front of our x. And that's going to give us x. Y. Now, is this my final answer? Well, it isn't, because I first need to check if I have any like terms. Now this is going back to some grade 8 stuff, where we realize that like terms, alright, are when we look at our variables and our variables only. We do not look at our coefficients. They do not impact on us trying to add or subtract like terms. So, my first variable over here is an x squared term. Do I have any other x squared terms? I do. I have a negative x squared. Now some of you might still be struggling with this, but if I don't have a coefficient in front of my variable, this simply means that there is an imaginary 1. If I have x amount of apples, alright, I have 1 apple. If I have 2x, it means I have 2 of them. So that's why we can just slot in our imaginary 1. So what is 3 minus 1? That's going to give me 2x squared. I do not change my variable. Once I've realized that my terms are the same, meaning they are like terms, so my variables are identical, I then go and perform the task with my coefficients. So 2x squared. Let's get rid of these now. Then I have xy and another xy over here. That means they are identical. So let's now look at our coefficients. A positive 7 and a negative 6. That's going to give me a positive 1xy. And that will be my final answer. Alright, let's take a look at our second example over here. I have two brackets back to back, which, as we know, means multiplication. So we got this bracket over here multiplied by my second bracket over here. Now, based on what we were doing last year with factorising, we might realise that we've seen this when dealing with trinomials. So they always ask us to say, here's a trinomial, can we then factorise it into two brackets? Now we've been given the two brackets. How do I get rid of these brackets? Well, we use FOIL. So we need to multiply the first term by the first term in the second bracket, the first term by the second term in the second bracket, and then do the same operation with our second term in the first bracket. Now, why did I jump straight to this? Well, I couldn't simplify what was in my first bracket or my second bracket, because 2x minus 3, those are not like terms. They do not share the same variable. Same in my second bracket. So what is this going to give me? Well, 2x multiplied by 5x gives me 10x squared. I first always like to deal with my coefficients, so 5 times 2, or 2 times 5, gives me the 10, and then x times x gives me the x squared. Now we're going to go 2x multiplied by my positive 1, which gives me a positive 2x, because 2 times 1 is 2. And then I've got negative 3 times a positive 5x, which gives me the negative 15x. And then negative 3 times a positive 1 is going to give me a negative, because a negative times a positive again is that negative answer, 3. Now the simplifying comes into place. I have only one x squared term here, so that will just drop down and become 10x squared. In the middle, I have two x terms. My variables are identical, which means I can add them. A positive 2 and a negative 15 is going to land me with a negative 13x minus 3. And that is my final answer. So, what do we notice? Well, this over here as my final answer is a trinomial. So, what I'm going to teach you next is how we go from this back into the two brackets. Alright, so on the board I have two trinomials. Now, the basic form of a trinomial is written in the form of ax squared plus bx plus c. Now, we're going to look at these two examples, and then we're going to find something very special about our c. So let's look at these two. Now, we know that when we're factorizing trinomials, that means we need to put these into two separate brackets. So let's go ahead and open those two brackets. Right, now, we know that if we're going to be finding our first term, what times what will give me an x squared? Well, that's going to be an x times an x. That is going to give me the x squared. So now we need to worry about how we can make a positive 5. So my last term and my first term are found by multiplying my first by my first, and then my last term, my c, is found by multiplying my second term by my second term, and the middle term is found by multiplying them all out. Now, how am I going to find, or how am I going to make a positive 5? Well, there's only one way to make positive 5, and that is 1 times 5. So we're going to go ahead and put a 1 and a 5. Now, the trick comes in, what signs am I going to be using in between these terms? Well, I'm going to tell you that because there's a plus sign over here, that means that both of the signs are going to be the same. So they're either both going to be positive or they're both going to be negative. Now, how do I know whether they're going to be positive or negative? Well, I'm telling you right now that if your c is a positive and my middle term is a positive, it's going to be two positive signs. Does it make sense? Well, we can always check by multiplying this out. So let's go ahead and do that. X times x gives me x squared. X times 5 gives me a positive 5x. 1 times x is a positive x. And 1 times 5 gives me that positive 5 that I'm looking for. So simplify gives me x squared plus 6x plus 5. And we get straight back to where we were in the start. Now, that's still going to sink in. You haven't yet realized what I was trying to say. But let's look at this one over here. What did I say to you previously? Well, I said that if your c, right, and when I say c, we're looking at this in its simplest form. When we look at this c over here, we notice that it's positive. And what did I say to you? I said if your c is positive, that means both these signs are going to be the same in our two brackets. And then with this example, I said this is a positive c, so both the signs are going to be the same. And then my middle term was also positive, which then said that it would both be positive. So now I've got a positive c. Both signs are going to be the same. My middle term is negative, which means I will have two negatives. Now I don't even have to worry about what signs to deal with. So let's look, how are we going to factorize this? Well, what's going to make x squared? Well, x times x. Now I know I have two negative signs in the middle. And what am I going to make 6? How am I going to make 6, should I say? Well, I've got 2 times 3, 1 times 6, and then vice versa, 3 times 2 and 6 times 1. But which of those, when added together, will give me 5? Now, not just 5, but a negative 5. Now, that was always a big stress, all right, in grade 9. How am I going to make a negative 5? But because I already know what my two signs are going to be, I don't even need to worry about that. So it's simply just going to be what makes 6 when multiplied together, but also when added makes 5, and that'll be 2 and 3. Now because they're both negative, it does not make a difference where I put these. So I can put a 2 or a 3 here, and because I put the 2, I've got to put the 3 over there. Does this make sense? Well, let's multiply it out to check. X times x is x squared. X times negative 3 is negative 3x. Negative 2 times x is negative 2x. And a negative times a negative is where I find that positive. So it's going to be a positive 6. Simplified, x squared minus 5x plus 6. Alright, so I just feel like we should sort of re-establish what happens with this positive c. I feel like it could be something you're not really just clued up on just yet. So what have I said when we have a positive c? Well, what I was trying to tell you was that if my last term, my constant term, constant being a term without any variables, if this c over here happens to be positive, what that means is when I open my two brackets, I know that both symbols are either going to be 2 pluses or 2 minuses. Now, how am I going to know whether they're both plus or whether they're both minus? Well, it's quite straightforward. All I need to do is cast my eyes over to the middle term and look at what symbol I have. Do I have a plus or a minus? I have a plus. That simply means that I'm now going to have 2 positives in my brackets. So now I can go ahead and factorize. What times what gives me x squared? Well, that's going to be x times x. Now, I'm looking at my c in order to find my middle term. So, what times what gives me 20? Well, I have 1 times 20. I have 2 times 10. I have 4 times 5. And vice versa. But the question is, which of those, when added together, gives me 12? The previous headache came, as I said, was all about which sign, what's got to be what. Does the 2 have to be positive? Does the 10 have to be positive? Which is which? But because we've now understood that if my c is positive and my middle term is positive, we'll have 2 positives, or if my c is positive and my middle term is negative, we'll have 2 negatives, that eradicates that whole problem. So now we can go straight ahead and go 2 and 10 will obviously give me my 12 when added together, so I can go plus 10 plus 2. And that is my answer. Again, if you want to try and solve it, you can then multiply these brackets out and find that we'll get back to the trinomial. Let's do it one more time with a negative. If I have a x squared minus 8x plus 15, we're going to use the same principles. So, is my c positive? Yes, it is. So I can go ahead and open my two brackets and say what times what gives me x? Well, x times x gives me x squared. And then I need to know, is my c positive? Yes, it is. What is my middle term? It's a negative. So it means that both my symbols will be negative. Now, what makes 15? Well, 1 and 15, and then 3 and 5. And vice versa, 15 times 1 is 15, 1 times 15 is 15, and the same with 3 and 5. But which ones, when added together, are going to give me 8? I don't have to worry that it's a negative 8, because I already know what my two signs are. So I can go straight ahead and say that I can use 3 and 5. And that will be my final answer. And I will quickly prove it to you because x times x is x squared. The x times the negative 5 gives me negative 5x. Negative 3 times x gives me negative 3x. And then negative 3 times the negative 5 will give me the positive 15. Simplified, x squared minus 8x plus 15. And that will take you back to our original trinomial just to prove to you that it is correct. Please do not put this into your exam. This is your final answer with 2 brackets. You have factorized, and that is your final answer. Okay, so let's get to some dots. You might have heard of this at school, dots. Now, what does this actually mean? Well, it's just saying the difference of 2 squares. Alright, it's not that important, alright? I've said it already, so don't worry about the horrible handwriting, but dots is the difference of 2 squares. So, what is the difference of 2 squares? Well, as it states, it's literally the difference of 2 squares. So in mathematics, we know what squares are. We know what difference means. Difference means subtract. 2 means 2 terms, and the squares will be perfect squares. So a prime example would be 16x squared minus 1. Now, can we factorize this? Well, of course we can. We can use dots. But there's 3 things to check. Number 1, are there 2 terms? Question number 2, is there a minus sign? And question number 3, are they both perfect squares? Those are the 3 questions we need to ask ourselves when dealing with dots. Now, the first 2 are quite straightforward. Are there 2 terms? Well, of course they are. There's 1, 2. As we know, terms are separated by plus and minus signs. Question number 2, is there a minus sign? Of course there is. It's right over here. And the third question is, are they both perfect squares? Well, this is the one that might be a little bit tricky for you, but it's quite easily solved. All you need to do is place a square root sign over both of our terms. And that will be able to tell us if they are perfect squares. So, can I find the square root of 16? Of course I can. The answer would be 4. And can I find the square root of x squared? Yes, based on the rules from grade 8 and grade 9, we've realized that if we square root a variable with an exponent, we simply need to halve the exponent. So that would become 4x. You could say to the power of 1. It does not change anything. And the square root of 1 is 1, because 1 times 1 gives me 1. That is one that often eludes children because they don't think anything times itself will give me 1. Now, let's move to actually factorizing this. What do we do when we have a difference of 2 squares? Well, again, we need to open up 2 brackets. Now, what happens is we need to have a plus and a minus sign. I'll explain to you why we have to do those, but for now, let's just leave them. So, what is the square root of 16x squared? We've found it to be 4x. So we place these 2 in the front of my 2 brackets. What is the square root of 1? Well, it's 1. So it'll be 4x plus 1 and 4x minus 1. Now, why? Why have I decided to use a plus and a minus sign? Well, I'm going to tell you now. If I did not use a plus and a minus sign, which I'll show you, I'm not going to have 2 terms as my answer, and I wouldn't be factorizing this as a difference of 2 squares. So let's go ahead and multiply this out and get back to what we have up top. 4x times 4x is going to give me 16x squared. 4x times a negative 1 is minus 4x. Positive 1 times 4x is my positive 4x. You might already have noticed that I'm going to be able to cancel things out here, and then a positive 1 times a negative 1 gives me that negative 1. So, now that I collect, I've got one x squared term, so it remains the same, 16x squared. And now I've got a negative 4x and a positive 4x, which are simply going to just cancel themselves out, and I'm left with a minus 1. Notice how we've now gone from where we started, and we've gone back there to prove to you that this is the correct answer. Sorry for the bit of mess, but let's get rid of this now. We've proven it. The final answer is 4x plus 1 bracket 4x minus 1. So let me do a bit more explaining with another example. Alright, so So we've got the expression 25 x to the power of 4 minus 9. Alright, we want to know if we can use difference of two squares to factorize this. Again, let's look at our questions. Are there two terms? Yes, there are. Is there a minus sign? Yes, there is. Are they both perfect squares? Well, let's check that out. So, can I find the square root of 25 x to the power of 4? Well, I can square root 25, that gives me 5. And then I can find the square root of x to the power of 4 by simply dividing my exponent by 2, as previously discussed. So the answer would be 5x to the power of 2. That's my first term. Now let's look at my second term. A 9. Can I find the square root of 9? Of course I can. The answer is 3. So let's now go ahead and factorize this. We said we need to have two brackets. Alright, we got the two brackets. What goes into the first part of each bracket? Well, I need to find the square root of the first one, which I've already done. So it'll be 5x squared and 5x squared. And then my second component of each bracket is going to be the square root of my second term, which is 3. And now, to ensure that we don't develop a middle term, I need to have a plus and a minus sign. Let's just put those in different colors to make sure that we can actually see those. And that is a plus and a minus sign. That ensures that we do not develop that middle term, which is very, very important. Right, lastly, for the difference of two squares, what I'd like to incorporate is a fraction. So, fractions are always something that sort of freaks people out, so let's deal with that one. If we have 4b squared minus 1 over 9. Alright, so now we got 4b squared minus 1 over 9. We've now incorporated the fraction. Can we square root a fraction? Well, this is another thing that students often have issues with. We feel like when we see fractions, the whole world changes. It doesn't. We simply need to use the same principles. This is what mathematics teaches us. We need to apply the rules that we are taught. So, let's first go ahead and ask ourselves the questions. Are there two terms? Yes, there are. Is there a minus sign? Yes, there is. Are they both perfect squares? Well, let's investigate. 4b squared, if I put that into a square root sign, am I able to find the square root? Well, the square root of 4 is 2. Deal with my coefficient first. And now my variable, the rule says I need to divide that exponent by 2, and that will leave me with 1, so it'll be 2b. Now, 1 over 9. Can I find the square root of 1 over 9? I can. The trick is square root the numerator. What's the square root of 1? It is 1. And what's the square root of 9? It's 3. Does that make sense? Well, 1 over 3 times itself should take me back to 1 over 9. And the rules of fractions, numerator times numerator gives me 1, and denominator times denominator gives me 9. So it is the square root of 1 over 9. We just need to apply the rule of numerator and denominator. Now that I've found that they're both perfect squares, what do I need to do next? Well, open up two brackets. What goes into my first part of each bracket? The square root of my first term, which is 2b. So 2b and 2b, and then the second component of each bracket is going to be the square root of my second term, which is 1 over 9. So the square root is 1 over 3. And let's not forget, if I'm to make sure that this does not develop a middle term, I have to have a plus and a minus sign. Alright, so let's give you two examples that you can go through on your own. And I'm going to give you two different examples and try and see if you can see which one is a trinomial and which is a difference of two squares. So I've got x squared, alright, minus 13x plus 36 as question number 1. And question number 2 is going to be 16x squared minus 4 over 9 as question number 2. I'd like you to factorize both of these for me, please. Alright, now that you've managed to factorize them, let's see if you got the answers correct. Let's deal with number 1 first. Number 1 has got 3 terms. That means it's a trinomial. So when we have a trinomial, as we discussed, we need to open up two brackets. But where does the help come from? Well, the help comes from our c being positive. Now, when my c is positive, we've then worked out that I need to look at my middle term to see what my signs are going to be. If my c is positive, it means that my signs in the middle of my two brackets are either both going to be positive or both be negative. To remind you, we look at the middle term to see what they'll both be, and because it's a negative, they're both going to be negative. So, how do I make my x squared? Well, x times x. Then, for my last term, how am I going to make 36? So, I need to decide whether I'm going to use 1 times 36, 2 times 18, 3 times 12, 4 times 9, and then 6 times 6. Which of those am I going to be able to use to put into the end of each of my brackets? Well, because we already know what the signs are, we don't need to worry about those. So we simply go straight for the one that when added together gives me 13. So we can eliminate 6 plus 6 because that gives us 12. That's never going to help us. That's never going to help us. This isn't going to help us either. So it's got to be 4 and 9 because 4 plus 9 does give me 13. So it's going to be minus 4 minus 9. And that is factorizing the top trinomial using the little trick of looking at my c and it being positive. Alright, let's go straight to number 2. I'm hoping you got the right answer for this first one. The second one, it's a difference of 2 squares. Why? Well, I answered those 3 questions because I have 2 terms, I have a minus sign, and I can square root both of my terms. So the square root of 16x squared, I open my 2 brackets, and that's going to leave me with 4x. So I place that in front of my 2 brackets. And then the last two is my square root of my fraction. And like I said to you previously, I need to square root both my numerator and my denominator, which leaves me with 2 over 3. So, to make sure I don't have that middle term, I must have a minus and a plus sign, and I put 2 over 3 and 2 over 3. And that is my final answer.